All right, so today we're going to do day 9, which is a continuation of Cramer's rule that you learned yesterday. You remember you can only use Cramer's rule if when you find the determinant is not equal to 0. And we're going to do that all by hand, so that would be on the non-calculator part of your quiz. On the other hand, if the determinant is equal to 0, which we're going to see today, you're going to either use reduced row echelon form or substitution or the elimination or addition method to solve the system by hand, which we don't recommend that you do because that'll take a long time. Instead, we're going to switch to the calculator, and you can use RREF on your calculator. So that would be the case on the with calculator portion of your quiz. All right, so we should remember some of the steps for Cramer's rule from yesterday. And the big thing is you're going to replace different columns in your matrix. You'll replace once in the first column, replace once in the second column, and replace once in the third column. All right, so in this first system of equations, we have 3 equations, 3 variables. All of the A's are lined up with the B's lined up, and the C's are lined up, and the constants are on the other side of the equation. So first thing we're going to do is set up a matrix that just deals with all of our coefficients. So we have 3, -1, -4, 1, 2, -3, 2, -1, and 2. The first row, first column, and I'm going to look at the number 3. So remember, you pretend that the 3 row gets wiped out and the 3 column gets wiped out, so you look at what remains, which is these 4 cells, and we've got a 3 out in front, and we've got another small 2 by 2 matrix where we're going to find the determinant of that. So it's 2, -3, -1, and 2. And then another thing we have to figure out is this going to stay positive or negative? So we always do -1 raised to the row number and column number. So it's row 1, column 1. So we're going to add those together. So the sum of the row and column where the 3 was located is 2, and -1 to the second power would still be positive. So this is going to be a positive 3. All right, then we're going to look at number -1 in here. So we're going to have -1, and we pretend that that row and that column get wiped out, and we're going to have a little 2 by 2 matrix based on the leftover 4 items. So we'll have 1, -3, 2, and 2. And then we need to decide what we should do for the plus or minus. So it's -1 to the first row, second column. So -1 to the third power would be negative. So we're going to subtract -1. And subtracting -1 really means that we're going to add 1. All right, and then we're going to look at the third element in that row, and that's a -4. And we're going to pretend that that column and that row are wiped out. So we'll have these 4 elements left over, and we make a little 2 by 2 matrix with that. So 1, 2, 2, and -1. And then we need to decide what to do for our sign. So -1 to the 1 plus 3, so -1 to the 4th power would be positive. All right, so now what we need to do is find the determinant of each of these little 2 by 2 matrices. So we take our diagonal, 2 times 2, which is 4, and then we minus -3 times -1, which is 3. So 4 minus 3 is 1, and we multiply that by the coefficient that's in front, which is the 3. So for that little section, we get the number 3. And then if we move on to the next section, we're going to take the number 1 and multiply it by the determinant of the 2 by 2 matrix, which is 2 minus -6. And 2 minus -6 is really 2 plus 6, which is 8. So 1 times 8 is 8. So we're going to do 3 plus 8. And then the last thing we're going to do is -4 times the determinant of this little 2 by 2 matrix. So -1 minus 4, and -1 minus 4 is -5. So -4 times -5 is 20. All right, so we need to add those numbers together. So 3 plus 8 plus 20 is 11 plus 20, which is 31. All right, so 31 is not equal to 0. So that means that we are allowed to proceed with Cramer's rule. All right, so now we're going to create another 3 by 3 matrix, but we're going to replace the first column with the answer column or the solution column. So instead of putting 3, 1, and 2, we're going to put 3, 9, negative 8. But then the other numbers are all the same, so negative 1, negative 4, positive 2, negative 3, negative 1, and 2. So now we have to find the determinant of this 3 by 3 matrix. We're going to follow the same procedures that we just did above. So we look at our number 3. We write a little 2 by 2 matrix with the leftover 4 elements. So 2, negative 3, negative 1, and 2. This will be negative 1 to the 1 plus 1, which is negative 1 squared, so that stays as positive. The next one, we're going to look at the negative 1, and we're going to look at the remaining 4 elements, which are 9, negative 3, negative 8, and 2. And this is going to be negative 1 to the 1 plus 2. So negative 1 cubed would be negative, so it's really negative, negative 1. And negative, negative 1 becomes plus. All right, and then my third number that I focus on is negative 4. So I look at 9, 2, negative 8, and negative 1. And I decide if this should be positive or negative. So negative 1 to the 4th power would be positive. All right, so now we're going to do 3 times 4 minus 3. And 3 times 1 is 3. And then my second section is going to be plus 1 times 18 minus 24. And 1 times negative 6 is negative 6. And then my third section is negative 4 times negative 9 minus negative 16, which is really negative 9 plus 16, which is 7. So negative 4 times 7. So that's going to be minus 28. So 3 minus 6 is negative 3, minus 28 is negative 31. We'll call this d of x. This original 31 that we got here was just your overall determinant of your original coefficient matrix. All right, so now we're going to move on to the second column. So we're going to take the second column and replace it with the solution matrix. So we're going to keep the 3, 1, 2, but we're going to put 3, 9, negative 8 in the second column. We're going to keep the negative 4, negative 3, and positive 2. All right, then we just have to repeat the same procedure. So I'm going to use the 3, and the 4 leftover terms are 9, negative 3, negative 8, and 2. And then we've got 3 again, and we've got 1, negative 3, 2, and 2. And then we've got negative 4, and we have 1, 9, 2, and negative 8. All right, so negative 1 to the 1 plus 1 is a positive because negative 1 to the second power is positive. Then we have negative 1 to the 1 plus 2, which is negative. And then negative 1 to the 1 plus 3, which is a negative to an even power, so that's going to be positive. All right, so now we need to do 3 times 18 minus 24. And 18 minus 24 is negative 6, which is negative 18. And then we're going to do negative 3 times 2 minus negative 6, which is 2 plus 6, which is negative 3 times 8. So that's minus 24. And then we're going to do negative 4 times negative 8 minus 18. So negative 4 times negative 26, positive 104. Because 2 times 26 would be 52, and 52 plus 52 is 104. So negative 18 minus 24 would be negative 42. And then when I add 104, I'm going to get 62. So that's equal to d of y, the determinant of the y's. All right, now I need to do the last 3 by 3 matrix. So we're going to try to squeeze this in here. So we're going to replace our third column. So we keep 3, 1, 2, negative 1, 2, negative 1, and we're replacing the third column with 3, 9, and negative 8. All right, so we need to do 3 times the determinant of this 2, 9, -1, -8 matrix. And then we're going to do -1 times 1, 9, 2, -8, the determinant of that matrix. Then we're going to do 3 times 1, 2, 2, -1, the determinant of that matrix. And then as a reminder, the first one is going to be positive. The second one is going to be negative. So minus a -1 is really going to be +1. And then the third one is going to be positive. All right, so we're going to do 3 times the determinant of the little 2 by 2 matrix, which is -16 minus -9, which is really -16 plus 9. So that's 3 times -7. And then we have 1 times -8 minus 18. So that's 1 times -26. And then we have 3 times -1 minus 4, which is 3 times -5. So we need to do -21 minus 26, that's -47, minus 15. So that'd be 57 and another 5 is 62. So that's -62. And that's the determinant of the Z column. We will need to combine and go back to all of our values. So I'm just going to write this up at the top. So the X solution should be my determinant of the X column 1, which is -31 over 31, which is -1. The Y should be the determinant of the Y column, where that one got replaced, which is 62 over 31, and that happens to be 2. And then Z should be -62 over 31, which is -2. So final answer for this one is -1, +2, -2. And I know these are a lot of work, but I think when you get nice answers at the end, then you'll know that you have the right solution. We usually don't give you crazy fractions as answers. All right, so that's just a reminder of yesterday's day 8 Cramer's rule. All right, so we're going to do one more, but this one's going to end up being a special case, so we're not going to have to do the whole Cramer's rule. So we're at least going to set it up and start it off. So we come up with our original 3 by 3 matrix representing all of our variables. So we have 12, we have 0y, and then we have the -11 for z. So 12, 0, -11. Then we have 6, 6, and -4. Then we have 6, 2, and -5. All right, so we're going to find the determinant of this 3 by 3 matrix. So we're going to look at 12, and then the 2 by 2 matrix that's left over. Then we're going to look at 0, and then the 2 by 2 matrix that's left over, and then -11, and then the 2 by 2 matrix that's left over. And then don't forget, we need to look at -1, the 1 plus 1, which is positive, -1 to the 1 plus 2, which is negative, and -1 to the 1 plus 3, which is positive. All right, so our 4 elements that are left over are 6, -4, 2, and -5. And then for the second column, we'll have 6, -4, 6, and -5. And for the third column being wiped out, we have 6, 6, 6, and 2. All right, so we're going to do 12 times -30 minus -8, which becomes -30 plus 8, so 12 times -22. And then we're going to have 0 times something, so we don't even really need to find the determinant of this matrix, but I'll do it anyway. So -30 plus 24 is -6, but -6 times 0 is going to give me 0. We'll figure out what 12 times 22 is in a second. Then we're going to do -11 times 12 minus 36. So -11 times -24. All right, so if we calculate this, so 22 times 12 is 44, and then 22, so 264. So this is positive 264. And then 11 times 24 is 44. and 22, which is 264. This first one should be negative because 12 times negative 22 is negative 264. This one is going to be positive. So as you can see, when we add those together, we get 0. So when we have 0 for our determinant, we cannot use Cramer's rule. So I don't know if this is a good thing or a bad thing, but at this point, since we cannot use Cramer's rule, you can now go to the RREF method on your calculator, right? So we're just going to solve this system like how we did earlier in the chapter. So we're going to create an augmented matrix. So we've got 12, 0, negative 11, 6, 6, negative 4, 6, 2, negative 5. Do our dotted line. Then we got our solutions, 13, 26, and 13. As a reminder, this is a 3 by 4 matrix. All right, so now you're going to use your calculator. So you're going to go to second matrix, move over to edit. You're going to hit enter. I'm going to use matrix A for my matrix. It's a 3 by 4 matrix. And I'm going to type in my numbers. So we got 12, 0. Remember, for negative 11, make sure you use the negative, not the minus. And we got 13. Then we have 6, 6, negative 4, 26, 6, 2, negative 5, and 13. All right, so I'm going to double check that I have all the numbers typed in correctly, because if one of them is wrong, then my whole answer is going to be wrong. And I'm going to quit out of here, and then I'm going to have my calculator do RREF of matrix A. So I'm going to do second matrix, move over to math. I'm going to scroll down to RREF, which is choice B. And then I have to choose the matrix that I want it to calculate the reduced row echelon form of, which is matrix A. So that's choice number 1. And then I'm going to hit enter. Get a weird looking matrix again. I'm going to change it to fractions. So this tells me 1, 0, negative 11 over 12, 13 over 12. We got 0, 1, 1 fourth, 13 fourths, and then we have 0, 0, 0, 0. All right, so what do we actually want to look at? We want to look at the last row, the one that has all the zeros in it. And this is the same thing as saying 0x plus 0y plus 0z equals 0. So we need to evaluate, is that true or false? Well, 0 does equal 0, so that is true. And since that's true, that tells us that we have infinitely many solutions. All right, for our last question, it says, find the value of x which makes the following statement true. So this tells us that the determinant of this 3 by 3 matrix is equal to 0. So we need to figure out how to get the determinant to equal 0. So we're just going to use our same method that we've been using before, where we focus on each of the terms in the first row. They just happen to not all be numbers. Some of them have variables in them. So it's x minus 4. We wipe out the first row in the first column, and we see what's left over. So we have x plus 4, 0, 0, x plus 1. And then in the second section, we have 0, 0, 0, 0, x plus 1. And then the third section, we have 0, 0, x plus 4, 0, 0. And remember, we look at our signs. This will be positive, this will be negative, this will be positive. And then we're just going to use our normal calculations. So x minus 4 times x plus 4 times x plus 1 minus 0. And we'll have 0 times 0 minus 0. That's nice because that's 0. And then we'll have 0 times 0 minus x plus 4 times 0, which is just another 0. And so we just need to figure out what this would be. This is x minus 4. Now we need to multiply. If we multiply this, we'll FOIL. So we get x squared plus 4x plus 1x plus 4. So we have x minus 4 times x squared plus 5x plus 4. This should all equal 0, because remember that's our determinant. All right, and then I'm just going to factor, because we've got this x minus 4, which is actually in parentheses here. If we factor this, we can use zero product property, so we have x minus 4. And then what multiplies to 4 that adds to 5 is x plus 4 times x plus 1. So I guess we really didn't have to multiply and then factor again, since it was already in that multiplied form. So that tells me that my answers are x equals 4, x equals negative 4, and x equals negative 1. And the question was find the value of x that makes the following statement true. Right, so we've got these three answers. All right, if you have any questions, ask your teacher in class.